problem that I'm doing is from section 7.1, number 5, and it's finding the inverse of the given group element. So if you look at the problem, it actually gives you a little hint how to find the matrix inverse, and this is the little formula for it. So starting with part A, we're asked to find the inverse of 2, 0, 2, 1 in Z3. So by using this hint up here, first we find the inverse of the determinant multiplied by 1, 0, negative 2, 2. So the first thing to note is you can change the negative 2 to a 1, since negative 2 in Z3 is 1. And then the inverse of 2 in Z3 is just 2, since 2 times 2 is 4, which is 1 in Z3. So from there, we're just taking 2 times this matrix, 1, 0, 1, 2, and that gives us 2, 0, 2, 4, which in Z3, the only element that we end up having to change is this 4, which is a 1 in Z3. So our final solution, finding the inverse of 2, 0, 2, 1, is actually itself 2, 0, 2, 1 in Z3. So in part B, it asks us to find the inverse of 1, 2, 3, 4 in Z5. So first we again find the inverse of the determinant times 4, negative 2, negative 3, 1, since you just flip-flop the A and D and then make the B and C negative. So the determinant ends up giving us a negative 2, and then in Z5, the negative 2 and negative 3 can be swapped out with a 3 and a 2, because negative 2 is 3 in Z5 and negative 3 is 2 in Z5. Another thing we can change is the negative 2 right here, and we can change that to a 3 in Z5. And now we're just finding the inverse of 3 in Z5, which is 2, because 3 times 2 is 6, which is 1 in Z5. So now we're just taking the 2 and multiplying it by our matrix 4, 3, 2, 1. And that ends up giving us 8, 6, 4, 2, which if we change in Z5, we end up getting 3, 1, 4, 2. So our final answer of finding the inverse of 1, 2, 3, 4 is going to be 3, 1, 4, 2 in Z5. So lastly, we're given the matrix 3, 5, 4, 6 in Z7, and we want to find the inverse of it. So we find the inverse of the determinant, and then switch the A and D and make the B and C's negative. So the determinant ends up giving us a negative 2. The negative 2 can become a 5 in Z7. The negative 5 becomes a 2 in Z7, and the negative 4 becomes a 3 in Z7. The inverse of 5 in Z7 is 3, since 5 times 3 is 15, which is 1 in Z7. So now we're just taking 3 times the matrix 6, 2, 3, 3, and we end up getting 18, 6, 9, 9, which if we convert in Z7 gives us 4, 6, 2, 2. So the final answer, finding the inverse of 3, 5, 4, 6 is 4, 6, 2, 2 in Z7.